Hello, welcome to the ECG webinar, Shaken Without the Earthquake. I'm Chelsey Sizemore, an associate member of technical staff with ECG. I'm joined today by Mark Lindsey, a senior member of technical staff. Welcome, Mark.
Hey, Chelsey. Thanks. I'm glad to be here.
All right, Mark Lindsey has been in networking and telecom for the past 8 years. Today, we are here to share a report on research conducted by several members of the ECG team. About 6 months ago, the law went into effect that requires 100% of voice service providers in the United States to be using stir shaken for all calls in their SIP portions of their network. The original legal motivation for stir shaken, as outlined in the Federal Trace Act, was to block illegal calls placed with fraudulent caller ID. And in other countries, such as France, the goal is to not only require stir shaken, but also to block all calls that are not signed with a stir shaken attestation. So blocking bad calls is on everyone's mind. So ECG wanted to see if that time had arrived for blocking using the stir shaken data. In particular, ECG wanted to find out whether the data available to service providers today provides the information necessary to accomplish the goals of blocking illegally spoofed calls. Here at ECG, we do many technical projects in voice networks. Some of that work over the past 10 years has been on blocking illegal calls in service providers and enterprises. In addition to numerous engineering projects to make service providers safer, we've been invited to present at the SIP Forum Conference and provide training within the federal government. Thank you to everyone who is joining us today. The purpose of this webinar is for you to gain confidence in how to use stir shaken today, along with good insight into the state of the technology deployment in the US today in 2023. In our agenda today, first, we will talk about the earthquake that can happen if you misinterpret the data when you implement robocall blocking. Second, we'll look at some issues we're seeing in the stir shaken network of today. And finally, we'll take your questions. After the webinar, look for an email from our colleague, Jade Darby, who will send you the slides from this webinar. We also have a technical report that goes into more detail than we can cover today. This webinar will wrap up at the top of the hour. Please send us any questions and comments you want answered. You can use the Q&A function in Zoom to type in your questions, and I will see them and we will answer them. Mark Lindsey is presenting this research. He has been working with technology to block spam calls for the past 8 years as part of the engineering work here at ECG. Mark, start us off by talking about what can happen if a voice service provider gets this blocking decision wrong.
Thanks, Chelsey. Great introduction. I wanted to give an example of what can happen in a voice service provider. So our scenario is we've got Faith, and she manages a voice service provider, and her largest client is a major contact center operated by Bob. And the problem is for Bob that these robocalls are interfering with business operations. So his agents are taking inbound calls. They should be coming from customers, but they're actually from various forms of illegal robocallers or scammers that are coming in and interfering with operations. And Faith wants to solve this problem. And so she creates a plan and sends notice to her customers that they're going to make a great new improvement, and they're going to provide protection. And before the end of the quarter, they're going to have the best protection around against this kind of inbound calls. So they integrate with a stir shaken provider, with an analytics provider, and look at it and say, hey, this looks like we should be able to provide a lot of great protection here. So the engineering team designs a nuisance call blocking solution to exploit the great stir shaken data that they're getting. It's coming in from all their different service providers. They test the solution. They make test calls. They test from their cell phones. They test from new lines. They test in all kind of ways, and all the tests look good. And then they put it into production in a maintenance window. You know how this works in voice service providers. They do these maintenance windows overnight. They run their regression testing to be sure everything went right and nothing broke. Everything seems to work great in their test. So they've made this, one small step for a service provider, but one giant leap to help their customers. Well, the next morning in our story, Alice tries to call Bob. So Alice is one of Bob's biggest providers. They're an Atlanta-based agrochemical manufacturing firm. And Alice picks up the phone, tries to call Bob, and the call doesn't go through. So Alice can't call Bob. She texts Bob, though. She pulls out her phone, texts, and said, hey, I tried to call, but it didn't go through. So she's texting his cell phone, and that goes through. The text does. And at the same moment, though, Bob notices that his call center stats are way off. So he's monitoring the analytics, he's monitoring his revenue, sales, the number of incoming calls, how long people are waiting on queue, and things just seem really way off. So only 25% of the normal sales volume has come in, which is a big deal for Bob. His occupancy is down, the sales numbers are way off. And that's a mystery. So he checks his advertising, he checks his Google Ads and other things that are putting out advertising and to check to see if that's working and all that analytics still looks good. He checks his staffing to be sure it's not a workforce management problem where he doesn't have enough agents on duty, but that looks good and he's got the right number of agents active. You can't find anything wrong. Why aren't customers calling to place orders like they normally would for this time of day? But Alex's text makes him suspect, well, maybe it's something about his phone system, his voice service provider. And so he picked up his desk phone, he calls the 800 toll-free number, and it immediately goes through. It goes right in the queue, just like it should. And then he talks to one of his employees, Sam, who works in that call center. So, Sam, Bob, this is Bob. Is your calls, are your calls working? Can you hear everyone? Is all the audio working? And Sam replies, yeah, Bob, it's working. But I can hear you just fine, but the volume is just not there. My phone's just, I'm not busy like I normally would be for this time. It's super slow. This is the end of the story. It's very personal now. And I've got to get some sales. I was really depending on making my numbers this quarter so we can make the down payment on this house. So the big deal for Sam. Sam is personally affected by this. And Bob replies like, no, don't worry, Sam. I'll work it out. We'll figure it out. Bob calls again. And this time he tries calling his contact center from his cell phone. That call goes right through. So no problem. So Bob cannot find what's wrong with this. Alice cannot call Bob for some reason, but every time Bob tries to make a test call, it seems to work. And so what's going on? Behind the scenes, Faith Service Provider is blocking calls without a valid stir-shaken identity. So that's the story. That's what created this earthquake in the network, was that they decided to say, look, we're getting the stir-shaken data, and now we're going to block calls that don't have a valid stir-shaken data. And now it's causing a massive outage. The reason that this is happening is because there are a lot of ways that stir-shaken data is not getting distributed through the American telephone network today, and that's what we're going to be talking about today. And most of rural America is connected through TDM tandems. They go through PSTN gateways that use TDM. And to use our example of Alice, her agrochemical business, fertilizers, is mostly purchased by farmers in rural regions of the U.S. And these are exactly the same folks who would be the most affected by a technology that has an impact on and requires interventions other than TDM. So what's happening, as it says on the slide, is that for service providers today in America, between a quarter and 3/4 of calls are not likely to have valid identity headers. And so Faith Service Provider, in all their testing, was doing test calls where they got valid identity headers. So making calls from cell phones, from major cell phone networks, making calls for their own internal system, all have valid stir-shaken identity headers. All of those things were working. So their testing was fine, except for they couldn't test from other parts of the network that didn't have the stir-shaken identity headers. They were kind of blind to that possibility that a substantial number of callers wouldn't have it. And so that's what we're going to talk about today, is kind of what's the backstory here? What could cause this kind of thing? Why is this the situation? And I want to make you aware, just like Chelsey said a minute ago, we want to make you aware of the reality so that you can make smart decisions about how you use and depend on stir-shaken data that's available today. So where do we get our information? So ECG is an engineering firm. We work with a broad variety of technology and service providers and enterprise and government customers. So we have direct kind of hands-on a lot of technologies, Metaswitch, Broadworks from Cisco, the Ribbon SBCs, Oracle SBCs, Stansay. We work a lot with Neustar. We work with TransNexus, a number of other companies that we work with in this space. So that's kind of the air we breathe for our regular engineering practice. But we didn't want to depend on our own experience. We wanted to talk to the service providers and the stir-shaken providers themselves. So we had some great conversations with engineers within these organizations. So one of our data contributors was a top 10 US-based voice provider, so one of the 10 biggest. They provided information. The team at Microsoft, who works on the Office phone system, they also provided data to us. Hiya made some public reports available about their customer, which includes data on their customer, which is AT&T. So Hiya provides some of the technology behind AT&T's network. And then we talked directly to 3 StirShaken software providers who provide software as a service and also just software for installation. So we talked to Newstar, part of TransUnion. We talked to Sansei and to TransNexus, and TransNexus was super helpful. They provide a lot of data to the community, and I'll show you some of that data that's coming up. So this is not based on our own observations alone. This is based on what we got from these different service providers who provided information for our study. So here's how we're going to walk through it. We're going to talk about 6 different questions. The first of which is the case of the missing identity. So we're talking about really StirShaken headers that just don't appear. So this is a SIP invite. I'm not going to go through a ton of detail, and it's mostly a prop, but I just wanted to point out here that we have a SIP invite for a call that's going through, and there's an identity header right here in the middle of it. And this identity header, you can see how it's kind of grayed out a little bit. What we're saying here is that on calls where the SIP invite comes in, but it doesn't actually have that identity header in it, then of course you can't do StirShaken analytics based on that. You're just missing the information. So it's hard to verify an identity header that isn't there. And a key limitation that everyone tells us is TDM gateways. When calls come in from TDM parts of the telephone network in America, then they're generally not including these identity headers. TDM gateways, just for background, they use 1960s to 2000s era technology, and that technology cannot natively deliver StirShaken identity header, although I will say there are methods for sending StirShaken data between TDM telephone switches. So this is a possibility technically, but it's actually not mandated by the standards. The FCC regulations don't actually require the use of those technology yet. So if you get an invite that comes into your network and it's got the identity header on it, then you can do the analytics. But if it's just not there at all, if it's just missing because it's coming in from a TDM part of the network, then or for any other reason, then you're not going to get the identity header. And so this identity here, these letters here, identity, this is what I'm referring to. This is the one key header that should be included by the StirShaken standard for traffic that's coming into a network. And it's also, if I was the one placing a call, if I'm a voice service provider, then my software is going to generate that identity header and put it on the call before sending it out. So this is the identity header that we're talking about. It's really right at the heart of this question. So a big question is, well, how many identity headers are actually making it through to the destination, or what we call the terminating service providers? So talking to these different companies and getting their data, this is the graph. So down here at the bottom, this is really our goal. We want 100% of authenticated calls to be sent through to all U.S. service providers. So this gray line represents kind of where we want to go. The best data that's available, the best quality and quantity of data that's available, Hiya reports that when calls come into their customers from mobile networks, then 89% of those calls include an identity header. So if you think about this is public information. It's widely announced that Hiya does work with AT&T. So if we think of this as coming into a major telecom carrier like AT&T, connected to other major telecom carriers, that nearly 90% of those calls are coming in with StirShaken headers, and that's great. But those are consumer to consumer calls primarily. Another, what we call service provider X here, one of the top 10 service providers, their long-term average is around 70 to 75% of calls come in with StirShaken headers on their calls. And so that represents their SIP connectivity. Calls to Microsoft, it's a lower number. They reported that it was about 2/3 of calls that come in with an identity header, which means that we're thinking, these are starting to get big numbers now, that fully 1/3 of calls coming into the Microsoft system network. And this is the Microsoft Carrier Connect. This is Microsoft Direct Trunking. This is Microsoft Office phone system type of traffic that's coming into their networks through SIP gateways. It's coming in with an identity header, which is to say 33% is coming in without. With Hiya, calls coming in from non-mobile callers, meaning from the enterprise callers who are coming in through landline phone systems or other carriers, but basically not part of the mobile network, then just over half of calls are coming in to their network with StirShaken headers. Now, if we look at the data coming into TransNexus clients, which is another user population, usually these are small to medium service providers, but TransNexus is a pretty major player, and they do a great job of delivering data to reporting data on these issues. That's as low as around a third of calls are coming in with an identity header, which means that the vast majority, 2/3 of calls are coming in with no identity header at all to the service providers. And TDM is likely the major cause of that, according to TransNexus and then all of the others we worked with. Neustar estimates that only about 20% of calls from enterprise customers going to mobile or consumer users actually even have the stir shaken header on it at all. So you can see it's a big range here, and the ones that the cases that are the most difficult to send stir shaken headers on are those calls coming in from enterprise networks, meaning businesses that want to make calls to consumers, and the vast majority of those cases do not have identity headers on them. So Neustar estimates that on average more than 80% of enterprise to mobile consumer calls do not receive any stir shaken attestation, which is corresponding to that 20%.
So Mark, is there anything in an intermediate service providers network, so in this case not the originating or terminating provider, that could strip the identity header from an invite request that goes into terminating provider's network?
Yeah, so you're talking about like the intermediate, so not the originating party, not the final terminating service provider, but one of those in the middle. Yeah, and that's a great question. The folks who operate the Traceback group say that on average, there's usually about 7 service providers involved in handling a phone call in the United States. So you can think of one originator, one terminator, and then 5 other service providers in the middle on average are involved in handling a phone call. So if any of those 5 are doing anything that could be dropping it, then yeah, that could make the call go away. So yeah, I think Chelsey, even if you had an originating service provider that was using SIP and they were sending SIP to another company, and then there's a TDM hop in the middle, then that would cause it to be dropped. You could also imagine cases where service providers have not done a full interop with maybe SIP over TCP, or maybe they're struggling with SIP over UDP with fragmentation, something like that, where they've had to they've clamped down the maximum packet size. That could be an issue where they just haven't done the interop necessary to allow that big block of data, the identity header, to go through. Another one could be, you can imagine a lot of scenarios. Some service provider networks, especially, there's a whole class of SPCs out there, which by default they only allow through a small set of headers. They define these are the headers we're going to allow, from header to header, contact via, just a handful of things. And they've never added the identity header to that list. And so those are cases where it could be dropped. Although, the standards, the FCC regs do seem to say that you really should be passing the identity header through unchanged. So yeah, I could definitely imagine cases where the originating service provider is actually sending the identity header, but then some intermediate along the way is dropping it off. So, and I think I've got a slide that'll touch on that coming up here. But it's a good question. So, another point we've seen as we talk to different service providers and operators was that for service providers, size is a big advantage. And so there's a big disparity between the largest and smallest providers, and that's really boils down to TDM. Large providers have more prolific SIP end-to-end connections, meaning they've got connections where it's SIP at each hop along the way, to most US phones compared to smaller providers. So if you think of a call going between one of the top 3 mobile providers that have direct SIP interconnect with each other, then the number of service providers involved is going to be really small, maybe only 2 in the perfect case, instead of 7, like I said, it could be in the average case. Some of the largest PSTN gateway providers are companies like Bandwidth.com, CenturyLink, Cinch, Verizon Business, a lot of providers that are USA Digital, a lot of providers that are like that, that do a good service, but these PSTN gateway providers, they're often able to provide origination service, meaning they can sell you a phone number in an area. That's how it's often said. I can buy a phone number in Atlanta, and I'm getting that, and that means that when calls come in to that phone number, they route in through my PSTN access provider, and then they route to me. And the way they do that in most cases is by connecting to the tandem, and most of the tandems are reachable only through TDM. And so in order to be able to offer service in all of these places in the country and beyond, they're often connecting over TDM, which it's not subject to the attestation requirements. And so calls flowing through TDM are not going to have identity headers. And so you see a big disparity there. The ones who have SIP-based connectivity end-to-end are the ones that have SIP connectivity into the tandems, or maybe they are the tandem operator. and they have some the ability to build those SIP interconnects versus those that don't. And so large service providers have kind of a largely different experience than smaller ones. So you see like my example here of the top 10 US service provider, they're getting 75% of calls delivered with identity headers on it. And it's because they've got good, robust SIP connectivity. So one TDM hop in a call can mean that no identity header is delivered, or that everything it could be dropped. It could also mean that a different one is created. And so, for example, here we've got a case where Alice is calling to Bob. Alice is, let's say, the yellow service provider. It's going through to intermediate service provider 1, then 2, and then let's say that there's a TDM SS7 gate link over to service provider 3. So for some reason, calling in order to get in here, maybe this is basically the tandem operator, that this call is routing over TDM at this leg. So service providers can generate a new attestation, a new identity header, and in generally intermediate service providers who do not have a direct relationship with the calling party, Alice or Alice's company, are going to use the C attestation because that's what it's for. It's kind of a gateway. It means that they don't have a direct business relationship with the calling party, and so they're generating a C attestation. So in this case, we go all the way through. We get in this particular example, we're getting a different identity header than the one that was originally generated. But this is not actually, this is a fairly new requirement. It's not enforced yet. So a lot of service providers, intermediate service providers, in fact, most intermediate service providers are not adding their own C-level attestation yet. Talking about this concept with one of our colleagues, Pierce Gorman at Numerical, he mentioned that specifically, there's a lot of reasons where maybe in the future, somebody who is kind of functionally an intermediate service provider may have additional information and be able to do a higher level attestation, but that stuff's not really on the books yet. It's being worked out. And so this is kind of what you might expect, is either a service provider that doesn't generate a new attestation after the TDM link as the call flows through, or maybe they generate a C in kind of the best case today. Big providers really just have more identity headers available. So like I said, our big provider has 3/4 of their calls showing up with identity headers. Microsoft is getting 2/3 of their calls with identity headers. And so there is a big difference there, big versus small, between service providers. So another question is, well, even once you get that identity header, why are attestations failing? Why are they failing? Remember in our story with Faith and Faith Service Provider, the engineering team blocked calls that didn't have a valid identity header. Well, in these cases, like we're talking about here, we're getting 3/4 of calls with identity headers or 2/3 of calls with identity headers. A lot of those identity headers are failing verification. And so why are those attestations failing, those verifications failing? And validation errors are really rampant. This is what we've heard from different service providers, is that and operators are seeing a lot of different reasons that these attestations are invalid. So number formatting or number mismatch problems, I've got another slide on that I'll go into. That's one of the most common reasons. That's really what people say is really the top reason, is the number formatting problems, where the phone numbers just do not line up between the data that's embedded in that identity header and then the calling information. So that's really the top one. We also have cases that are reported of expired certificates where you're doing everything right, but you're just not managing your certificate right. So the certificate is not a web server certificate, but it has it in common. And some of you who work on web server certificates may know that they have an expiration date that they have to be managed. And so you can go and let your certificate expire. One of the cool things is the technology actually, Stir Shaken Technology actively advocates for using something called Acme, which will automatically keep your certificates refreshed. But reports are from the SIP forum meeting recently in September that most of them are not using it. There's very little use of Acme right now. There's a lot of folks who are manually updating certificates, and that's kind of a recipe for allowing it to expire, unfortunately. So that's a technology area that can really help boost this. That's something some of you on this webinar may be able to take as an action item. Recycled identity headers are another thing where people are hard coding in one identity header and they're just using it over and over. That's actually something that's happening a good bit. And this may be an effort to appear to be compliant with STIR/SHAKEN without actually doing all the hard work. Another one that's actually surprisingly common is just time synchronization problems, where your server that's used to generate the identity header, it actually has to have an accurate time and date. It's not really that hard to do it, but it is a common mistake to forget to synchronize the server's time with a time server. It doesn't really cost anything. It may require some firewall security rules, but it's something that is actually happening pretty frequently, according to our different STIR/SHAKEN service providers, operators. They're seeing time synchronization problems where the timestamp put on the identity header is just incorrect. So I said I would dig in here to the number formatting problems a little bit. So here's one where we have number formatting causing a validation failure. So in this case, we've got the to header. So this is from the SIP header itself. So this is the old-fashioned to header request. So this is, a 10-digit US phone number. It's a very common way to encode them. We've got user equals phone, which means that this is to be interpreted as a phone number. And then inside the identity header, we actually have to decode it in order to read this. It's base 64 encoded. So if you look at that slide where I've got the identity header, it just looks kind of like gibberish. Well, that's actually base 64 encoding. It's not encrypted. It's just an encoding to deal with all the complicated characters. And once you decode that, inside there's a destination telephone number. So that's what this refers to. So this is just a little snippet of that, what's called a passport. And it's got in here a telephone number 229-316-0013. Well, this looks fine. These look like the right numbers, right? Except that the standard says in the United States, we're going to encode it in a particular way. We're going to encode it starting with the country code. So it should be encoded more like this one here, where we've got 1 followed by the rest of the phone number. So a 10-digit phone number inside the identity passport is not going to be correct in the US. Here's another example, a different scenario. Where you've got something like simultaneous ring or find me, follow me feature, where in this case, it's my desk number. So this is my phone number here. So my desk number, and when somebody calls to my desk number, it rings over to my cell phone and it rings my desk at the same time. It's a very common service. And so it's placing this call out to my cell phone number. So pretend this is my cell phone number. It's going there. But the system, let's just say, is going to reuse the identity header, the same one that came from the PSTN is being reused on the way back out. Well, the call that came inbound to my number actually has the telephone number in the proper format for my desk. It doesn't have the destination telephone number of my cell phone, and so that's really the problem. These two numbers don't match at all. And so this is also going to be a case where we get a verification failure, because this just looks like the wrong identity header. It needs to, for this scenario, it needs to be regenerated. And actually there's some technology to enable you to say, where this call came from and to indicate that this is effectively a call forwarding situation. So there are ways to signal this, but that's not what the STIR/SHAKEN operators are seeing today when they look at the data. They're seeing a lot of cases where they just see two different phone numbers that are showing up in the headers. So, I've got this diagram here showing just a few scenarios of the kind of thing that can happen. So, for example, this top one here, you've got the from number and the originating telephone number. So this is the from header, from number from the SIP header. This is from the STIR/SHAKEN identity header. And you see these don't have the canonical format, it's called, with the country code. So this is missing the country code. It's an incorrect number formatting. That's going to fail verification. You've got this one where the numbers are not matched, like the case on my previous slide, where the call is being forwarded and the token, it's called, the passport or the identity header, these are all synonyms in effect for our purposes today, that it's being reused, and that's creating a problem too. So that's going to fail validation. You've got another case that shows up, we see sometimes, where the certificate itself is inaccessible, or like I said, it's got the wrong expiration date on it. So this is happening where there'll be a certificate that needs to be accessible across the internet, and it's just not. And so the verification fails because it's not accessible. Or is another case where the date is just wrong. We just have the wrong date stamp on this call. So that's another potential type of case. So in all of these cases, the verification is going to fail. And so the terminating service provider is not going to have any good way of verifying that these were legitimate. But in all these cases, what we're saying is these are legitimate calls. These are legitimate calls where, for various implementation problems, the STIR/SHAKEN verification is failing. So we're going to talk next about the problem of the third-party certificate. This was raised by several of the expert engineering and service provider teams that we talked to as one of their big concerns. So even with a valid attestation, one of the big limitations is when another party is providing the certificate. So right now, this is apparently allowed under current FCC regulations, but there is a notice of proposed rulemaking where they're asking questions. The FCC is asking questions about whether they want to allow this to persist. But that's on the regulatory side. On the operational side, what I'm hearing from the operators, from the stir-shaken providers, is that this makes things pretty difficult for them, the way this is being done today. So Alice, in this example, is making a call. Alice is buys service from the green service provider here. So that's green. And then that goes to the pink intermediate service provider. Well, the pink intermediate service provider doesn't have a direct relationship with Alice, but does have a relationship with green. So basically, this is a wholesale SIP trunk. And the pink service provider is adding an attestation to this call, an A-level attestation to this call. And right now, that's I'm not going to make any comments about whether that's legal or illegal. That's not really my role. But this appears to be an acceptable behavior. It's just a behavior that doesn't allow us to know the identity of green. So the pink service provider is saying that we have the relationship with the caller Alice. So we have the ability to know that Alice is using Alice's phone number, or a phone number that Alice has the right to use. And so we're going to add the A-level attestation. And then in the perfect world, this is going to flow through all the other intermediate providers. So the terminating service provider is going to get an attestation with a certificate from the pink service provider, which is why our seal is pink here. So as far as a terminating service provider perspective, this looks like the call originated with pink. They cannot tell the identity of green at all. So we lose the actual true originating service provider in this definition. But we do get stir-shaken information through the network. And this is valuable, certainly. This gives us some help, because if we can go back and talk to Pink about it, and we'll have some comments on this later, then obviously Pink is going to be able to help us figure out where these calls are coming in from. It's just now we're not going to have the original information. And Pink is also going to be using the same certificate in most cases. What's happening today, they're using the same certificate in most cases with many different versions of green. So many different of their customers are getting basically attestations are created using the same certificate. So they're all kind of masking behind the pink service provider. And this just makes it hard to identify kind of who the calling service provider is in this case. Even with valid attestations, we can have that problem. And then there's another one, which is where the incorrect attestation level is being used. So I know there's a lot of discussion about what the A, B, and C levels of attestation mean. It does not help that this thing has been made into a law, that it's required. And so now we have standards documentation that was written for implementers, technology implementers, and now we're having to parse through it to figure out precisely how to do this. And so working with my colleague, Alec Finishel at TransNexus, we are going to propose not these replacement definitions, but just descriptions of what the definitions are saying. So the A-level attestation, looking at the ATIS 10074 standard, is really saying that if you're using the A-level attestation, that you are the originating service provider with a direct relationship with a calling end user or enterprise, so that's the customer, who is using their own number, which we have verified. And when we say their own number, it's a number that they've been assigned to or they have the right to use. But in addition, part of my role as the originating service provider is I have verified that they have the right to use it. So that's a key thing. And this is completely compatible. You can go read ATIS 10074. I recommend you do. This is what we're saying is effectively intended to put really the FCC language of originating service provider into that standard, and also some of the language that's used by business leaders who need to work with this kind of thing. So, for example, a direct relationship could be that we have a business relationship and we're selling them a SIP trunk. That would be a very normal kind of direct relationship. So the B-level attestation sounds very similar, except it just softens the levels of guarantees we're making. So it says that with you'd use B-level attestation if you're the originating service provider with a direct relationship with a calling end user enterprise. But I can't say anything about the phone number that's being used. So I'm not going to make any assertions that they have the right or they don't have the right to use the number. I haven't checked it, I haven't verified it. So that's what the B-level attestation is intended to be used for. It just means that as the originating service provider, I'm still getting a call directly from an end user enterprise. I'm not getting a call from a service provider. That's what B means. But I have that direct relationship, but I can't verify their number. And C, the C-level attestation effectively is equivalent of saying, I'm receiving this call from another service provider, or maybe from somebody, maybe an end user who is forwarding the call. So the call has maybe flowed through. So I gave the example of the call forwarding cases where the call comes into my desk number and it also rings my cell phone, but that would be a call forwarding scenario. And so C-level attestation would be, an appropriate option in that particular case. These three are intended just to be descriptions to kind of help in this discussion. They're not really replacements. A lot of great work went into developing what we have today in the standards, but the standards were really largely targeted at standards developers. And there is a little bit of internal jargon, and there's some things like telephone number legitimacy and some things that aren't quite as defined maybe as we need them to be at this point.
Yeah, Mark, I know you're proposing these clarifications for the different levels of attestation. Are they not like clearly defined in the standard? Is that why you're kind of providing kind of clarifications or simplifications of them and worked with other people?
Yeah, I think you could say that they're clear, but they're being confused. So, one of my first mentors in business made the statement that communication is the responsibility of two parties. So if I'm talking to you, Chelsey, then it's my job to make myself understood, and it's your job to understand. Well, that's a responsibility on both sides. And I think the recipients of the standard, the folks who are reading the standard, and then ultimately the folks who are not reading the standard, but they're sometimes still involved in making the decision about the attestation levels, they're having to deal with the business consequences of using C instead of A and other things like that. These are hard decisions to make. Those folks who are receiving that and making those decisions are basically demonstrating there's a lot of confusion out there, that there are a lot of variations in how these things are being interpreted and put to work. And so what we want is for folks to have good quality information with which to make those decisions. So it's not really a comment on the clarity of the standards. I can read it. I think what they mean is just fine, but it also helps that, to be perfectly honest, a lot of us who've been working on this for a while, we actually have relationships. We go back and forth with the people who develop the standards. Whereas what we really need are some definitions and some applicable rules of thumb and some caveats that we can work from that are a little more available to business leaders and regulatory leaders and the lawyers who are part of our community who need to make decisions on what to do. Because making decisions about A versus B versus C can really mean a loss of business or a gain in business. And so we really need to deal with what the true costs of these are. So we're just trying to make it a little bit more accessible for the business leaders, for the regulatory leaders who need to be able to implement and make these decisions. So it's a good question. I'm really not trying to redefine anything. I think you should go read the standards, and then I'm trying to provide a lens with which to do that. So one of the challenges when you have TDM and there's maybe a C-level attestation added, or you use third-party certificates where another company is adding their own attestation on there, is that you're masking. You're basically kind of hiding who the originating service provider is. TransNexus says the most valuable source of information in Shaken should be the identity of the originating service provider. And in both of those cases where we've got traffic going through TDM links that it's not using out of band Shaken, or you've got traffic going through and a new attestation is being added by an intermediate provider. In both of those cases, you're losing information about who the originating service provider is. So we've actually seen some cases where service providers are just choosing to never use C, even though C is mandated in the standard for many purposes. They're just never using C. And so we'll see where only A and B are being used. And so that's really a shame, because C has a legitimate function. It communicates something very important. I want to, as we're talking about this, I want to look at an example of a major legal robocaller who is active. So this is, if you're a service provider, you're going to see traffic from this organization. It's a U.S. government agency. They place millions of robocalls per month. And if you look at them from the perspective of one of the largest providers, about 90% of calls are attested and 10% are not attested. Meaning we get identity headers coming in from about on 90% of the calls. So one potential explanation of that is that about 10% of the calls convert. And part of the reason for that might be there's diversity inside their contractor network, or that they're using multiple contractors for intentional diversity. They have a vendor diversity in effect. And my looking at the data that I've seen, I believe that my hunch is that they're probably using vendor diversity, where they intentionally have two different vendors and they're sending their calls through both. They're sending most of their calls through one, and then but they have the other one and they send some volume through it to be sure that everything's working. Very smart strategy, but in effect, they're still getting 10% of their calls from a U.S. government agency that is involved in life and safety and national emergencies. That when they're making their calls, about 10% are coming in with no identity headers at all to a major service provider. And this is a major service provider that generally gets a very high percentage of calls arriving with stir-shaken headers. So it's important to remember that there are, of course, legal robocallers. They're using multiple vendors. There's not like a single vendor that has the right to use this number. This is an agency that has the right to use this number. And this has been studied. Addis is working on this. They published some material on this particular kind of use case. So it's important for everyone just to be aware that this actually happened. And still, this legitimate caller does have the need to place high volumes of calls. They're totally authorized to do so. And yet their calls are going to show up with no identity header at all. And so back to, if you rewind to our story about Faith and the service provider, what you'd see is that these calls would have been blocked. If your policy was to block calls that don't have a valid or verifiable stir-shaken identity header, then you're going to end up blocking these calls. So that's just one thing you want to be aware of. So how do we do blocking? You know, that was the headline promise of this talk. We're going to talk about, well, how do we do blocking? So one thing I want to point out is that everyone agrees that shaken data is valuable for traceback. Even with the limitations that we've got, it does give some useful information about how the call came back. The traceback value, this is according to Newstar, part of TransUnion. The traceback value of stir-shaken has been and will continue to be useful. We believe that calls that ostensibly would be subject to spam tagging or blocking are going to be those from landline to consumer. And so this is Newstar is really pointing at one of the biggest challenges here, which is that enterprises that are attempting to make calls to consumers through the PSC are struggling the most with tagging, incorrect labeling as spam calls. And in effect, what we're doing is we're telling consumers not to trust the calls coming from businesses. But the shaken value of using this for traceback is definitely there. So when is it advisable to block calls? Well, I would say not yet. That's this consensus opinion. All experts advised against blocking based solely on the available 2023 stir-shaken data. That's the consensus opinion from every single one that we talked to. They recommended against using stir-shaken data to make a blocking decision. So how do you block calls with stir-shaken? I think someday this is not going to be a no. It's not going to be a not yet. The action item is to begin verifying and analyzing the stir-shaken data that you are getting today. What I'm observing, what others are observing in the industry is that too many U.S. service providers are sending identity headers, but they're not performing verification. We've actually already seen where the FCC did an enforcement action where a service provider suffered some penalties and restrictions because they said that they were not doing verification on incoming calls. So this is an issue that's not only part of the regulations, but the FCC actually cares about it. That's on public record. But we're seeing this in many cases. There's a lot of cases where there's been no effort put into verification whatsoever. It's not that you're working through the technical details or you got an implementation project or that it works sometimes and not other times. It's just that they're not even trying. They're just doing outbound identity headers. And it's an action item you should take is to check to be sure, are we getting the data and using it as much as possible? How do you handle blocking? So you need to do blocking. To be honest, you need to have some way of making decisions about whether to block incoming nuisance calls, spam calls. You need to, generally speaking, I'm saying this from a business perspective, that businesses who are providing calling services, termination services, meaning the calls are coming inbound to your customers, need to have an answer to how to stop illegal robocalls and nuisance calls from coming in. And the best answer, then the consensus is that the analytics platforms that can detect nuisance robocalling are really crucial. So I'm talking about companies like TransNexus, Haya, First Orion, TrueCNAM, TNS, Newstar, Mutare, Redshift. These are all companies that are providing technology that are able to make solid decisions. And generally speaking, what they're telling me is that stir shaken is only a relatively small part of that calculation, if at all. But what you want to do is plumb your system. You want to send the data through so that the stir shaken data is sent to the analytics platforms. Some would argue that outright blocking will never be a great option. So, for example, our friends at Microsoft suggest that maybe sending it to voicemail is always going to be the right option. I don't know that that's the final opinion on the product team at Microsoft, but that's at least one option that they're discussing, or they're proposing that we discuss, really, is don't block, just send it to voicemail. The voice captcha service from Mutare is a really popular feature. It works well. And we're seeing that deployed. I know they did an announcement where you can get access to that both for your enterprise and through some of the UCaaS providers. But voice capture, where it goes through and you ask a question, you get some sort of interactive dialogue. That does a good job of checking on whether the caller is a live human that's able to interact. So there are other options besides blocking. So you want to keep that on your mind, that maybe blocking is not the final answer. Maybe you just will develop a product that goes a different direction. And again, this is the kind of engineering that ECG does. And so we take the product ideas that you have, and then we implement that and make those come to life in your network by providing technical engineers to do that. So how do you handle blocking? Really last slide on this. Is shaken data usable for automated labeling today? Actually, yes. And so this is an interesting quote from TransNexus. Calls signed with a B-level attestation are far more likely to be robocalls than unsigned calls. So you got to catch that. Basically, the B-level attestation is marking as serving today as a signal that the call is very likely to be a robocall. If you look at that, here's a graph from their data last month. We see the B-level attestation. These are calls that they have using other nuisance detection mechanisms have determined to be robocalls. So we look at the difference between the B-level attestation calls versus the A-level attestation calls. So this is actually a pretty powerful signal of the likelihood that a call actually is robocall. So if you haven't done this calculation yet and you're looking at a B-level attestation call, you're saying at least 4x is likely to be robocall if it has a B-level attestation. Well, that's actually kind of not what we hope to get out of that. B is really just an indicator of the quality of information we got about the caller ID, but it's actually being used by illegal robocallers today. That's interesting. So this is almost like a backwards look at it. And so, the bottom line is stir shaken data is going to be useful in ways that you don't expect. Because this is an example of, I don't think that necessarily we expected that the B attestation was going to function as such a strong signal like this. So it's going to be useful in ways that you don't expect. And so what you need to do today is get that verification into your analytics platforms as soon as possible. You need to get that data into the flow so that you can start to look at it, and so that your analytics, your nuisance management, their validation and treatment platforms are able to have access to it and they can start to make decisions. So that's where I think we want to recommend that you go, is move towards getting the data available into your analytics systems. I do want to repeat, I should say, that if a U.S. service provider is using stir shaken as part of a blocking solution, so if you're going to go ahead and decide to use this for blocking, then the service provider has to operate some kind of non-customer contact center. So some way for folks who are not your customers to contact you to say, hey, our calls to your network are getting blocked. This is based on some of the wording of the regulations on this. And it's just good practice to say, hey, we know that our analytics platform is going to get it wrong somehow, but we don't want to block calls that shouldn't be blocked.
All right, thanks, Mark. It was surprising to hear how few calls are actually have the stir shaken attestation. So let's look at some of the questions we have, and just a reminder, you can send them in through the Q&A function through Zoom. So first question, you mentioned before when going through the SIP invite and the identity header that it could be fairly large packet coming into the network. With this possibly cause problems for service providers that are using UDP, the protocol for SIP instead of TCP?
It definitely could. So you would need to have your SBC set up expecting to send fragmented SIP. So in a lot of cases on a wholesale SIP trunk, you're sending relatively small SIP messages, maybe 700, maybe 800 bytes. The upper limit, technically, is typically 1,500 bytes technically, but then in the standard, they say anything above 1,300 bytes is probably likely to get you in trouble. And so, if you're going from a packet that's 800 bytes to now it's going above 1,300 bytes, some systems are just going to have problems with that. They're going to block the call with a SIP response that says message too large, or they're going to there'll be some other problem related to the packet size. So yeah, it's a good thing to bring up that UDP implementations may take some extra work. Now, from what we've seen on all the SBCs, and like I mentioned, we've worked a lot with Oracle SBCs, with Metaswitch Perimeter and Ribbon on the core, the carrier side. I haven't done this exact thing with Sansei, but we've worked with them as well. But basically the SBCs, the carrier side SBCs, are going to have facilities for sending through large UDP. It's a common thing to do. So I think probably the most likely gotcha will be, well, if we're doing work with consumer devices, so you've got SIP phones or maybe WebEx for BroadWorks clients or something like that, where you've got a SIP software that's meant for an end user, then those devices usually already do send fairly large SIP messages for that application, that hosted PBX type application. Whereas on a wholesale SIP trunk or a PSTN connection, you're more likely to not need it. You're less likely to actually need big SIP. So this might be an area where the bigger SIP becomes more of an everyday occurrence. So yeah, some work may be necessary there. Sometimes it's going to be a pretty minor thing, though, of being able to up the limit or change a little configuration to allow that to go through. But if you try to put it in place, you add the identity headers, and then suddenly you start getting calls blocked, and you didn't expect to get to have a problem with large UDP, then that could hold some people back. It's a good question.
Okay, thank you. So in the case where you mentioned that an intermediate service provider is signing the calls, what would be the motivation for them doing that?
Well, so there's multiple reasons. So an intermediate service provider, and we're really using, when I use that term in the presentation and in the tech report, we're talking about, I'm kind of using the FCC definition of it, which means it's a service provider that's receiving calls from another service provider. But they're not a terminating service provider. So it's receiving it from one service provider, it's handling them in the middle, and then it's sending it to another one. And obviously I'm being kind of informal, but meaning it's not coming in from a SIP trunk going to an enterprise. It's coming from somebody else who, in the FCC world, in the US, they file a 499A paperwork. They're a real service provider. So that intermediate provider, there's a couple of reasons. One would be that it would allow them to offer a stir shaking service, which is technically allowed under the rules today. Although, like I said, the FCC in their notice of proposed rulemaking is talking about what they think about what they call third-party signers. Their term definition of third-party signer is really broad, but it includes these intermediate service providers that are using their own certificate to sign calls. So that's one thing. They could basically see it as a value add service, and we see a lot of that. A lot of service providers are offering this as a value add, something it's a feature, so that their originating service provider that's in this call, the originating service provider doesn't have to implement the technology themselves. My recommendation is that the originating service provider really should implement it themselves. That gives them control, and then they can send their calls through a number, and then they're also identifying their calls as coming from them. And it's also just the design of what stir shaking was intended for, as opposed to having an intermediate do it. So it could just be a value add service. It could be, another reason might be that they're implementing under the new standard, the new rules that have been published. They may add a C-level attestation simply because the regulations say they should. That calls coming in, it shows up to, I'm an intermediate service provider, it comes into me, it doesn't have an identity header on it. And so my new job under the new rules is to add my own identity header and just say, hey, I don't know exactly who originated this call, but I know who I am. And that's all. That's all I know is who I am. And so I just put a C-level attestation and say who I am. So a C-level attestation can be used in that way. So that's one of the other motivations for doing so, is just basic compliance with new regulations. There are some safe harbors, which means some service providers currently are not doing that kind of thing because they're participating with traceback. But my guess is the majority reason is the first one I mentioned, which is that it's a value add service where I can, as a service provider, I can add SureShaken under the rules today. I can add SureShaken headers on there. And then my originating service provider customer doesn't have to do that.
Mm-hmm. Okay, gotcha. So let's say it's the case where an intermediate service provider is using B attestation. And then the terminating provider gets that and does validation on it. Is there any way for the terminating service provider to know that a call is attested wrong? So using the wrong attestation?
So your scenario is truly the real originating service provider, they use the B. Is that right? And then they are sending it through, and finally, ultimately it makes its way through the terminating service provider, and they see it comes in as a B. But in reality, it probably should have been a C, but they can't, can you tell? Should it have been a C? Should it have been a B?
Yeah.
Yeah, really not. I mean, no, because there's no other information that's available there. That behind the assumptions of all these attestation levels, there's something about the know your customer policy. So how do the service providers interact with the originating enterprise or user or service provider? How do they interact? Like, what's their business relationship like? And so obviously as the recipient, you're only having information about that. I can, on the case I said of the U.S. government robocaller, I kind of have some hunches because it's a federal government and there are certain things in common, the way the federal government does business. But I don't really know. So I'm guessing, making some guesses there. So really the quality of that information is really low, like what you can guess after you receive the call. A lot depends on the originating service provider using the right attestation level right from the beginning, because what that means is the kinds of verifications that they have done on that. It's not unlike other kinds of examples where somebody needs to give an attestation. So for example, if you go to your bank and you meet with a notary and you have some documentation you want to sign, then the notary is going to check your ID, or they're going to do whatever your state requires to check to be sure you're really you. They're going to watch you sign it. They're going to check your, confirm that you're really the right person. Well, when they put their stamp on their notary's seal on it, they're attesting that they have followed the procedures that are necessary for their notary privileges under the state or their jurisdiction where they're operating. So, and then when you receive the document as the recipient of a document with a notary stamp on it, that's really what they're making an attestation that they have followed the right rules. And that's one of the reasons why we want to double down on clarifications of an A, B, and C level attestations to be sure that those are getting through. Because right now you got a lot of people who are putting stamps on calls, and there seems to be a lot of debate over what A, B, and C really mean and what they should be there for. Great question.
Okay, thank you. Could you talk more about the difference between blocking a call as opposed to labeling a call as spam based on the attestation?
Yeah, that's a great question. I moved past that. Let me see if I've got so here we've got a slide. I'm going to start sharing again just because I've got a slide that shows a picture of a label. So labeling is what's happening whenever you're terminating service provider. So the person who's ringing the phone of the final recipient of the call. So that's your phone company. They're receiving this call and they are putting a indicator on that. Like in this picture, it shows robocall. And so that call is coming in, it's labeled as robocall. So this would be labeling. So when you see a call that comes in and says spam likely, that's labeling. And what Neustar is basically saying, just to give an example, is that that's happening in a lot of cases to enterprise callers that are calling through to mobile consumer users who are getting a call and the calls are getting labeled as spam likely in a lot of cases. And a lot of that seems to be related to the fact that enterprise callers are having a lot of difficulty getting identity headers all the way through to the consumers. So but nevertheless, this is what labeling is. It's when that caller ID or some other indicator on your screen of the final recipient of the call is showing something about the call. It's usually something not happy. So spam likely, scam likely, robocall, that sort of thing. Telemarketing, political, could say things like that. A lot of different service providers can make those labeling decisions. And as far as I can tell, there aren't a lot of jurisdictional rules or regulations about what those labels are. In some cases, we're seeing where the service providers are just using the labels. They're inventing the labels and the wording that they want to use for those calls. And so this is labeling, but the call is not being blocked. It's still ringing your phone, and that's the difference from blocking. So whereas with blocking, the scenario would be your phone would never even ring as the recipient. The call is going to just go away. It's going to be discarded. Whereas with labeling, the call goes all the way to you, but it actually is, you're getting some sort of indication. This is a sort of a safer option because you're still ringing the customer's phone, the end user recipient's phone, but you're giving them some sort of clue as the disposition of the call. But unfortunately, we're not really helping ourselves as an industry by mislabeling. Calling all of the enterprise calls spam likely is not helping things because it's really not helping us restore confidence and value in the telephone network. But that's a great question, and I'm glad you brought that up because it lets me clarify the difference between blocking and labeling.
All right. That's all the time we have for today. I want to thank you all for joining us, and we would love to continue the conversation. Those of you attending today will receive a copy of the tech report that ECG produced for this research. You can also email us at sales, SALES, at ecg.co. Okay, thanks, Mark.
Great, thanks, Chelsey. I appreciate it.
Of course.